This is lesson 6, balancing redox reactions. So both oxidation and reduction must occur in order for a reaction to be a redox reaction. Here's an example. The nickel-cadmium battery. Here's an example. The nickel-cadmium battery uses the following redox reaction to generate electricity. Cadmium solid plus nickel oxide plus water goes to cadmium hydroxide plus nickel hydroxide. Identify the substances that are oxidized and reduced. So the first thing that you have to do in order to identify the substances that are oxidized and reduced is assign oxidation numbers. So for cadmium, it's just an element, so it's an oxidation number of 0. In nickel oxide, oxygen is -2 for a total of -4, so nickel must be +4. Water, oxygen is -2, so hydrogen is 1.
Hydroxide. Hydroxide is an ion in one charge. That's +2. It must be +2 in order to balance out. Again, over here, oxygen is -2, but there's 2 of them for a total of -4. Hydrogen is +1 for a total of +2. And nickel must be +2 in order to cancel out. So we can see that cadmium goes to cadmium +2, okay, which means that it must have lost electrons, 2 of them. So if it lost electrons, that means the cadmium is oxidized. Remember, oil rig. Which means the only other thing that changes oxidation number is the nickel. Nickel goes from +4 to nickel +2, which means that nickel must have gained 2 electrons to go from +4 to +2. So that means that the nickel oxide is reduced. Half reactions are equations that show either oxidation or reduction alone. Here's an example. Tin ion, tin +2, plus 2 iron ions, iron +3, goes to tin +4 plus 2 iron ions +2. So in order to write the half reactions, the first thing we need to do is determine which species have oxidation numbers that change. So we can see that the tin is going from +2 to tin +4, which means it must be losing 2 electrons because it's going from +2 to +4, and since it's losing, that's the oxidation half reaction. Remember, oil rig. The iron, therefore, is going from iron +3 to iron +2, and there's 2 of them, so each one is gaining 1 electron for a total of 2 electrons. You can see that you have 2 +3s for a total of +6, and you have 2 +2s for a total of +4. So the iron is gaining 2 electrons, which means that is the reduction half reaction. So in order to balance redox equations, there's some special steps that you have to follow. Usually balancing redox equations happen in acidic solution. So the first step that you're going to do is to divide the equation into 1 oxidation half reaction and 1 reduction half reaction. So you need to be able to figure out what's being oxidized, what's being reduced. The second thing that you're going to do is to balance each half reaction, and you do this by first balancing elements other than H and O. Then you balance oxygens by adding water. Then you balance hydrogens by adding H+. And finally, you balance the charge by adding electrons as needed. The third step is that you multiply the half reactions by integers as needed to make the electrons lost in oxidation equal to the electrons gained in reduction. After that, you'll add the half reactions together and cancel anything that appears on the left and the right.
and then you check to make sure the atoms and the charges are balanced. So here's an example. Balance the following equation. Permanganate plus oxalate goes to manganese ion plus carbon dioxide. So the first step is to identify what's being oxidized and what's being reduced. So the manganese is going from manganese plus 7 to assign your oxidation to +2,
which means the oxalate must be changing as well. So here I eliminated the permanganate and the manganate, did it, and now I'm going to assign oxidation numbers. So oxygen is -2 for a total of 8, which means manganese must be 7. That's going to manganese +2. In the oxalate, oxygen is -2 for a total of -8, which means the carbon must add up to +6, because remember the overall charge is -2, so each carbon must be +3. In the carbon dioxide, oxygen is -2 for a total of -4, which means carbon must be +4. So here we can see that manganese is going from +7 to +2, which means it must have gained 5 electrons. And the cadmium, so because it gained electrons, it's being reduced. In the oxalate, the carbon is going from carbon, it must have, so it's being oxidized. So we have our two half reactions. Now on to step 2. The next thing we have to do is balance atoms other than oxygen or hydrogen. So we have one manganese, but down here we see we have 2 carbons and only 1 carbon. So we have to add a 2 to this side so that the carbons are balanced. Next, we have to balance oxygen by adding water. So we have 4 O's here, so we need to add 4 waters on this side. Here we have 4 O's, and here we have 4 O's, so we're okay. Next, we balance hydrogens by adding H+. So we can see we had 8 hydrogens here, which means we need to add 8 hydrogens on this side. Down here we're good because there's nitrogens. So I'm just going to rewrite the equations so that we know what we have so far. So again, in our reduction, we have 8 plus permanganate goes to manganese ion plus 4 water. And in our oxidation, we have oxalate goes to 2CO2. The next step is that we need to add up our total charges on each side. So here we have 8 positives and a negative, so +7, and here we have +2. So now we have to add electrons into balance. So 7 positives plus 5 electrons gives us the +2, so our charges are balanced. And here we have a total of -2 and 0, so we have to add 2 electrons to the right side. The next step is that we need to multiply the entire equation by a number in order to get our electrons to balance. So we have 5 electrons and 2 electrons. So the lowest common denominator is 10, so we're going to multiply the first equation by 2 and the second equation by 5. So again, we are going to rewrite. We're going to distribute. So we have 10 electrons plus 16 hydrogens per manganate. And we have 8 here, plus 20 here is 28. And we have 10 carbons and 10 carbons, so we're good. And we have 8 here, plus 20 here is 28. And we have 10 carbons and 10 carbons, so we're good.
Here's another example of how to balance a redox equation. So complete and balance this equation by the method of half reactions in acidic solution. Here we have dichromate plus chloride goes to chromium ion plus chlorine. So again, the first step is to pick out your half reactions. So
After, and here's plus 3. So chromium going to chromium plus 3, which means it must be gaining electrons, so it is this. And chloride is going to chlorine 0, losing electrons out. And then changes fudges. So we are going to plus dichromate goes to 2 chromium ions plus 7 waters. We need to be so 14 H pluses. And then changes fudges. So we are going to plus dichromate goes to 2 chromium ions plus 7 waters. We need to be so 14 H pluses. Plus dichromate goes to 2 chromium ions plus 7 waters. We need to be so 14 H pluses. So 14 H pluses.
Okay, lastly, if we're balancing redox reactions in basic solution, you have to use OH minus instead of H plus, because OH minus is base, H plus is acid. So you're going to do the same thing that you did before as if it was an acidic solution, but then at the end you're going to count the number of H pluses in the half reaction and add the same number of OH minus to each side of the half reaction. And then finally at the end you'll cancel out your water molecules. So let's